Awesome. So I'm going to start by sharing my screen. Okay, I'm assuming we can see, everyone can see what's on my screen right now.
We can see.
Okay, awesome. Okay, so hi everyone, thank you for coming. My name is Hunter, and as Paige said, I am the project lead on the basic respirator project, which I've been working on since last March, right as soon as the lockdowns happened. It actually started because I was 3D printing PPE for local hospitals, and that prompted me to come up with a new design. A couple weeks later, I found JOGL and got some funding and really kicked off this project and got it off to a great start. Originally, it was gonna be like 3 days I was gonna work on this when I first started, but then, and of course, you know, I think we all thought that in a couple of weeks, the lockdowns would be over and everything would be fine. But of course, we're now here, November 12th, 2021. And this has, the project has kind of blown up into a mission. And it's something that I'm really passionate about. So I invited you here to talk about specifically virtual fitting for PPE. And I have a mobile AR app that I'm going to demo for you a little bit later. But I wanted to talk about this, just the problem itself, why it's so important to me and why I think it's so interesting to solve. So I'm a systems thinker and I'm interested in complex systems. I'm a hardware and software engineer, which is full of complex systems, things that have multiple inputs and outputs and interdependencies. And it creates a situation where if you change one of the inputs, it has an effect on the entire system. I also learned about design thinking and about wicked problems, which if you haven't heard about wicked problems before, it's something that came from social planning in the 1970s. But I think it's an interesting structure to understand the nature of complex problems that involve people, because wicked problems are essentially people problems. They're social messes. They are impossible to solve. They again involve a lot of people. Every different stakeholder has their own worldview and ideas on how to solve the problem. There's a lot of resistance to change, which I think is the most important. People are, you know, they say that they embrace change and innovation, but the reality is when it comes down to it, it's very, very hard to affect change, especially within a big complex system such as this. So moving on. So the problem that I've spent most of my time thinking about in the past 20 months involves N95 respirators. This is a wicked problem. It's not a new problem, but the pandemic did surface a lot of issues, starting with the supply chain, not being able to get, you know, not only not producing enough PPE for people and respirators, but also not getting them to the communities where they are needed most. And there's a lot of reasons for that problem. Fit and comfort are another problem, which I'll talk about later, and is something that I'm actively trying to solve. And then there's a huge problem that I think is going to have a long-term disastrous impact, and that is on environmental sustainability. We're paying a steep environmental cost because most N95 respirators are single use, especially those that are used in healthcare. And currently the stats, I don't have the stats for respirators themselves, but I know the stats for single use masks. We're throwing away 129 billion of them a month. So that's 3.4 million a minute. And it's 13 minutes into this, into our call today. So imagine how many masks have been thrown away just in the time we've been on this call. And as the pandemic is now becoming endemic and air pollution is increasing, you know, this problem is not going away. It's probably going to get worse. I've taken a look at a lot of market data on N95 respirators, and the market's just going to continue to grow. There's going to be more stringent requirements. People are going to need more respirators, and they're going to be throwing more of them away. So I attempted to map this problem myself. I divided it. This is just problems with N95 respirators in general. And I have this on a Mira board, and I'll share a link with you later. But I've divided it into 5 main drivers. There's obviously infrastructure and technology, political, economic, social, and environmental. So there's a lot happening here. All of these areas are highly interconnected. And there's no heuristic available for fixing a problem of this complexity and scope. So essentially it's unsolvable. We can't solve the problem with N95 respirators. It doesn't matter how many people we put on the problem. It's just not going to happen. But something you can introduce is this idea of an intervention. So you take action, like we can zoom in on some of these areas. For example, one of my main issues is women don't have access to PPE that fits. You can take action on this area. You can understand some of the interdependencies, some of the reasons that's driving this. It's partly economic, partly caused by the infrastructure and the way that they're manufactured, even political too. And you can take action on this area and try to introduce an intervention to this problem to alleviate some of the pain, and then test it and validate it, and see how it affects the rest of the system. And then through iteration on that sort of testing, validation, redesign phase, eventually you come to a treatment that works, and you have the data to support that this treatment works. And so obviously this is a common technique used in medical research, and then also social planning as well. And so N95 respirators, it is a medical problem, but it's inherently a social problem. So for the next few minutes, I want to hone in on this area about PPE fit. And that's what the app is about as well. Let's go back to my presentation. So in my research, I've done a lot of research on this. In my research, I learned a staggering statistic that over 70% of healthcare workers worldwide are women, and many are people of color. Yet they're wearing personal protective equipment that is designed for white men. There are updated size standards, at least in the US. We have an organization that updated the standards, but manufacturers aren't using them. They offer very few sizes, and of course the smaller sizes are high demand. So this creates a huge safety issue, and it creates a safety issue with the people that are on the front lines that are already burnt out addressing this pandemic. These images are from the early days. I think a lot of them are from the elastomeric respirators that people had to wear, but you can see some of them are, a couple of these people are wearing even single-use masks. I think what's happening in this image is that respirators need to be tightly sealed against your face in order to meet the N95 standard. And when you wear a device that is too large for your face, you need to tie it really, really tightly to get that good seal. And after you wear it, 8-12 hours a day, it's gonna cause bruising, it's gonna cause sores, and it's gonna cause dermatitis and who knows what else. They're very uncomfortable to use in healthcare. And again, this, the pandemic surfaced this problem that, respirators are designed more for short-term use and not necessarily for long-term use, and not necessarily for healthcare either. So we need to take another look at that. So, to start, in order for a healthcare worker to find a respirator that fits them in the first place, we have to measure and fit test them. So in the US, we have a organization called the Occupational Safety and Health Administration, OSHA, which mandates that all employees that are required to wear respirators to do their job, they have to be fit tested at least annually, every single employee. It's a labor-intensive process, which makes it costly, but the policy is in place to ensure that employees are issued a respirator that fits them. One example is the Qualitative Fit Test, where you need to wear the respirator and put a hood over you, and there's a bitter solution in there, and you vaporize the bitter solution in the hood, and you read a poem. And then if the mask doesn't fit well, you have to try the whole thing again. And each time you have to clean this hood out. And I think it takes about 30 minutes, maybe per person. The test is a little bit shorter. And so, that's an issue. And with quantitative fit testing, this requires expensive lab equipment, and that takes time as well. And so, during normal times, this is a headache, but you have to do it to ensure safety. What's happening with the pandemic and during a crisis is I'm learning that a lot of the hospitals aren't doing this at all. There's way too many people to test. And the supply chain shortages also caused a shortage in the supplies for fit testing. And so, hospitals aren't necessarily following the rules, understandably so. And so this is it's creating a safety issue. So this is my idea of an intervention to help solve this issue. So Quipfit is a mobile app that makes fit testing faster and easier. And it has a few more features that I can talk about later. But what it's going to do is it's going to collect basic demographic info, and then it's going to scan your head in 3D. We've designed an algorithm that determines your mask size based on national standards for sizing. Since I'm in the US, this app is using guidelines from the National Institute for Occupational Safety and Health, NIOSH, who governs respirators and the rules around them. And it also makes fit predictions. You don't see it in the screen here, but it's going to help you find the make, model, and size of mask that will fit you best. And then you can use AR to virtually try on the device to ensure it fits with other equipment. This is an early demo, so we're kind of at the MVP stage where you can do the 3D scanning, you can do the measurement algorithm, and then you can find your mask size. And I think later on we want to make it a little bit more accurate and scientific, and add some other features too. So so this is a draft of the study design. What we want to start with is to do a UX pilot in healthcare institutions. And we want to test the accuracy of its measurements, and then also the fit predictions for masks. So thinking about starting with one hospital and testing it on, maybe 100 or even more participants, we want to compare how well this app is able to make, sizing and fit predictions compared to the process that the hospital is currently using. And then we're going to compare that. We're going to compare those two processes, like an A and B comparison, and find out which one is more accurate and whether or not the app is indeed more accurate. And then we're also going to collect feedback on it as well. We want to collect feedback on the process. And then as we refine the app, we'll recruit more hospitals and participants to gather more data. I know that each hospital operates differently. And so we want to find out, what methods are they currently using, both for measurements, and then also just to make the determination of what size that is. Again, since the sizing guidelines are a bit all over the place, how do they choose what make and model of mask to wear for employees? How many masks do they offer? Are they actually looking at the gamut of mask sizes and manufacturers that are available and finding the right one? Or do they maybe just have 2 or 3 different sizes and see what fits best, and then they just tie it around your face really tight just to get it to fit and pass the test? Those are some of the things that I want to find out. And so, back to this sort of systemic problem. It might be an unpopular view, but the older I get and the more I work with technology, I realize it's better at creating new problems rather than solving them. So I want to see how this technology works within the system as an intervention. And again, just focusing on fit testing and finding that respirator size and taking a look at that process. How does that help, or does it create new problems, and how do we solve those? So we're going to interview healthcare employees and capture some of the feedback to find out about that. And then we'll also have some data to analyze too. So we're going to map facial scans, and as you can see in this app, the facial scan is pretty accurate. Obviously, we're not going to have the photo, and we're going to keep it anonymous. But again, this creates a new problem. It's an ethical problem. This is highly sensitive biometric data that should be kept private. And of course, there's laws in the U.S. to deal with this, but I'm not sure worldwide, what's happening with that. And with me as a company, introducing this, data privacy is a huge deal to me. And so we're going to have to work on that problem too, to ensure that the data is protected and remains anonymous and isn't released. Because this is, I still find this creepy, even though we made it. I find it a little creepy. So then another problem we're tackling is the design of the respirator itself. And you saw a brief glimpse of this at the end of the app. So this is the respirator that we've been working on, the basic respirator, it's a very old version. low polygon model. But this is the basis for the design. It's designed specifically for healthcare and first responders. It's designed to fit women. And it should fit at least 95% of the US population. Ultimately, ideally, we'd have a custom fit respirator, and that's another solution that we're working on. But I think for right now, just offering, just meeting the size standards that are that were created by NIOSH, the updated size standards, and offering more sizes, will meet that 95% mark, and that might be good enough. I did work with a first responder on the initial design, so we added some features that would be helpful for them when they're out on the field. And so what we're going to do is after, I think the UX pilot for the app, there's going to be several phases. And so while that is continuing, we're going to reach back to some of those hospitals and some of the people that were originally fit tested, and give them a respirator to test. But what I'd like to do is have them test it, in the hospital during a shift, and find out, after they wear it for, a number of hours, how does that feel? Is it more comfortable? Is the sizing better? Does this, fancy magnetic harness, really help with donning and doffing? Another aspect of this too is that the respirator is reusable. So we're going to have to do some testing on the environmental impact on it. My company is a part of a clean tech incubator, and so one of my responsibilities during the incubator is to prove that this, technology that I've developed is actually going to make a significant reduction in waste, in medical waste. And so we're going to come up with some ideas how to do that. And there was actually recently a paper that was published about this that I just got in my email last night, so I haven't had a chance to read it. But I like this little graph that I took from the paper, and unfortunately the credit is not there. But it's the impact of COVID-19 on waste management. So it's taking a look at, really it's the circular economy for how plastics are made, and how they're used, and how they're disposed. And again, back to this. This is a whole nother, system of problems that requires an intervention of just, trying to reduce medical waste, and trying to reduce the impact on the environment that these devices have. And so there's a lot of research to be done on this. Again, circular economy, how the masks are made, how they are distributed, shipping, logistics, sanitization, what's the impact on sanitizing these masks? What is the environmental impact of that? Is that better than disposing of them? There's a lot to unpack here. But I think it's interesting, and it's, I guess for me as a systems thinker, it's fun. So let me take a drink because I need to. So this goes back to JOGL, and just how to solve wicked problems itself through intervention. You need multiple interventions to tackle a wicked problem, and those interventions will each individually alleviate some of the pain that's contributing towards the greater problem. Ideally, the intervention should be small and feasible. I have this whole big grand solution in my mind of how I would fix the N95 respirator problem, but the reality is I don't know. But I do know a couple of different areas with the app and with the mask that I think are small and feasible enough that could potentially have a big impact on the entire system, and that's what I'd like to test. And so where JOGL comes in, and why I was excited to do this demo with JOGL, is that they're an interconnected community of people coming together to clean up messes exactly like this. There's a lot happening from the top down as well. There's a lot of huge organizations with tons of resources that are, doing this exact same thing. But in the research on wicked problems, they find that actually the bottom-up approach works best. You need to target the people that are having the most amount of pain, and those are the people that are at the end of the cycle. In this case, the healthcare workers that are wearing the masks. And since I started this project by addressing the needs of healthcare workers during the shortage, I got a lot of really great information on how we can do better, and how we can help them more. So, we need an interdisciplinary team to be able to tackle something like this, and a bottom-up team. So as I mentioned, I have a startup. So the startup is Material. And even though this is an open science project, I've turned this into a company. And I'm trying to get some grants. I've had a few, and I'm going to be applying for more grants. And then as I add more people on my team, I need more people to help me research this and to help me test this. And so that's why I wanted to get this demo today. And that's why I'm working with JOGL is in the hope to find people to work with us. So here is my, if you are a researcher, healthcare administrator, practitioner, and in general, if you are as interested in solving this problem as I am, I definitely want to connect. I have zero experience with medical device manufacturing. This is definitely not my area. I'm a hacker, and I've built a lot of wonderful complex things, but never anything like this. And I think that's, it's interesting that I'm approaching it as an outsider, because I think I have different ideas than a lot of the people who are already entrenched in this industry and might have some habits of thinking. And this little mirror board that I created, it's live, and there's a link here, and it should be pretty easy to type in. I'm going to have to figure out how to add collaborators, but you can at least view the board. And if you want to be a collaborator, then go ahead and just ask me or request or send me an email or something, because I'd love to have other people contribute to this. It's actually fun. I've barely spent, since I just came up with this last night, I've kind of barely spent any time mapping it out. But once you start creating these little sticky notes, you can just very quickly find, you can find where what is driving this problem, and what other problems it's driving towards. And it's actually kind of fun in a horrible way, because it's just like, oh, this one leads to global warming, and this problem leads to more illnesses and deaths, which is not fun, but at least we're trying to solve it. And so again, I'll leave this screen up here with my contact information, and I am happy to take any questions. I don't know, I can't see the chat right now, so I can't see if there were any questions in the chat, but and just discussion in general. I don't know if anyone here has been working on this problem and has any insights, but I'd be happy to hear that too.
Thank you so much, Hunter. That was really, really interesting, and just so real as well. I'm actually wondering, you've mentioned it, but your next steps are basically to kind of get feedback on this app to see how well it's measuring against what hospitals are already doing. And then in parallel, kind of test the basic respirator itself as well.
Yeah. So we're gonna start with the app and with fit testing, since it's a little less costly. And also, when I had planned with JOGL, I think I'd planned to do a pilot of the respirators earlier this year. But what I found is there was no accurate way to measure people. So I wanted to get the app done first, and get their measurements. But there's this other utility to the app as well, and that maybe we can start helping hospitals now in helping people find the right size respirator that fits them. So that's the purpose of doing the UX pilot. So the app is part of an integrated solution, but then it is also its own separate thing that doesn't necessarily have to involve the respirator. But then after that, we are going to follow up and test the respirators themselves in facilities.
Can I ask you a question?
Mm-hmm.
It's fairly quiet.
Hey, Adrian.
So, okay. Well, it is my impression, and I think it's more than an impression, that the healthcare it's something very, very hard to penetrate. It has built around a barrier of a moat and a thick wall and powerful warriors to keep competition down, and it's riddled with like standards and little islands of power and influence and stuff like that, and it's fairly hard to, it's complicated to even understand, yet alone to tackle. And I'm sure that maybe you don't have to necessarily agree with everything that I said, but you probably bumped into some of these so far. So my question is, because I know at least two more, because you were talking about the bottom up approach. I think I know at least from my experience, two more kind of groups of people that use masks like kind of daily basis as part of their job. That might be a little bit of a softer target for your product, at least at the beginning.
Mhm.
Okay. So, because it's very hard to bring it straight into a hospital, as you know, it's very complicated. So I know that people in molecular biology labs that work with viruses, they do have to have masks, okay, and 95s. Well, depending on the level of the lab. So those groups are usually smaller. They do have standards, but I think they are more flexible. It's not as complicated as a hospital. So you might be able to find some, even if you send some like, dry emails there, uh, asking if they would be interested to do like a small pilot or to try, you might be able to find somebody who would accept and would go for that,
Mhm.
which might be a plus in terms of testing, and also a plus for the moment when you want to to go to the health part in there. And there's another group. There's some, so you have these animal research facilities where I mean, it's still molecular biology, but they have like animals in cages, like mice and stuff like that. And usually the caretakers of animals and people that have access to those cages, they are mandated to use N95 masks. Okay. Because potentially the animals can have viruses, etc., etc. They cannot use like surgical masks and stuff like that. They have to be N95.
Mhm.
So again, some of those, and some of those might be, there are not too many in the university settings, but they might be even in the university. So those might be, if you approach them, it might be a little bit more, it might be a little bit easier to run a pilot in there, or something like that, than try to do the same thing with the hospital. Plus,
Mhm.
so I don't know. I would probably try to, kind of, search some of this and offer kind of like, hey, would you be interested to do this? It might be an easier thing than trying to solve all the problems that and all the standards and all the overhead and complications that you have with the healthcare system, which is usually very very rule rich and poor in transparency and flexibility,
Mhm.
and receptivity, I guess. So that's one of um,
Yeah, I think that's a good point in starting out small and then expanding. I had a pilot program it wasn't really a pilot program, it was more of a user testing program last year, where I sent out devices to I think it was a lot of it was first responders and also care workers that visit people's homes to care for the elderly. Um, and uh, but yeah, starting with a smaller group, because that group has similar but then different needs that I agree are a lot less complex than hospitals. But I have hospitals interested, so they're interested in it for their own research too. They're interested in the research and then potentially adopting it as a solution. So we're going to move forward with that. But I'm going to I'm going to take your advice and keep that in mind. I want to contact microbiology labs anyway, because I need someone to test the sanitization process on the masks and find out which one is effective. And then we'll probably have to test a few different methods and see, because there's a combination of, is it effective, but then also how many times can you sanitize the device before you have to throw it away? And, maybe something like UV light might be more effective than an autoclave and reusability. So I wanted to contact some labs anyway. If you know of any in the US and particularly California, let me know. But I'll make that as a to-do item to look them up. Thank you. Any other questions from people? I want to know what brought you here. Like, if anyone wants to speak up and just tell, I know I don't want to put you on the spot, but if you want to speak up and just tell me about your background and what it is that interested you in coming here today, it'd be great to know too. And if you are experiencing any problems or if you are just curious about the research. Okay, well, I'm going to put my, one last time, I'm going to put my screen on. If you'd like to get in touch, the incubator that I'm a part of lasts for the next year at least, and I'm signing up for another program that might extend it to 2 more years. So I'm gonna be working on this for a while. And of course, everything is I'm gonna keep the JOGL page updated. I haven't updated it in a while, but I'm gonna put some of this new progress on there and also the Mira board as well. And LinkedIn is probably going to be the best place to follow me for updates and to follow the project and see what's going on. So once we start testing in facilities, I'll add that information. And then once the research is published for the community, I'll add that up there too. And email, I'm always available. You can follow me on LinkedIn too if you want to connect, and if you have a skill that you think would be great to contribute to the project, or you have suggestions or what have you. But otherwise, I appreciate everyone coming today and listening. And if you aren't here and just listening to the webinar, thank you for doing that too. Yeah, so, and thank you, JOGL, very much for hosting and for, this, I think you gave me 500 euros to start out, and it's just kind of exploded into, I don't know, my whole, it's taken up my whole life. But it's fun and it's been good, stressful, but experienced a lot of growth too. So I appreciate everything that you've done.
Thank you, Hunter. We're just so excited about what you're doing. And just to recap, so you're looking for people to kind of test this app and give you feedback on it, for help researchers on this kind of Miro exercise, but also much wider in terms of kind of the industry. You were also looking for data analysts at some point. If we're making a call out, would those be the 3 big things? And for the participants as well?
Yeah, I've never designed a clinical trial before, so I figured it out. But if anyone does have that expertise, I'm definitely looking for that. I will probably get some with the hospitals that I plan to work with, but I am definitely looking for that. And then data analysis, because again, some of it's going to be on the measurement accuracy. But then as I start adding more and more users to the program, I'm going to start to collect a database of face scans and measurements and demographic info and location info, geographic info that I think will be interesting. And it's kind of like a, it's finding out who is actually on the front lines and what is their makeup and what are the problems that they're experiencing. Right. And hopefully that can add to some of the research that's being done with surveys and stuff. But we'll just add another, another component with this interesting data that we're able to collect.
Thank you so much.
Thank you, and take care, everyone.
Good luck.
Thank you. Good to see you, Adrian.
Are you done?
Yes.
And I can ask one more question. Sorry.
Oh, you can. Yeah, go ahead.
Sorry, I just came in, and sorry if you've already addressed this, but is there any connection to manufacturing the mask? If you're able to now measure and fit properly, what's the plan to interface with manufacturing and therefore large scale assessment?
Yeah, I mean, there's a couple different, because one of the interesting things about the and I didn't address this, but one of the interesting things about the mask itself is there's 3 different production methods that I can use. Each one of those is going to have to be tested and regulated, but there is an opportunity for 3D printing most of the components. Cut and sew is another one, and then injection molding too. I know with manufacturing there is especially in the US, localization is a big deal, and so we want domestic manufacturers to be making masks here, and I imagine it's the same for every country. But then also localized manufacturing is a lot more environmentally sustainable. So that's going to be part of that. Part of that is, in the design of the mask is considering, and that's just the whole idea of the circular economy, is considering where are you getting the raw materials, how are those being sourced, how is the mask designed, what is the impact of environmental sustainability on the manufacturing process itself, and then again looking into shipping and distribution and packaging, and then of course ultimately disposal too, and as I mentioned, sanitization for usability. So there's a lot to take a look at, but this is an area. I do have an industrial designer that is very experienced with manufacturing that's on the team, but definitely looking for assistance with that too, if anyone wants to contribute to that or just has ideas. And this again will be information as I collect it that I'll publish on JOGL. To share with the community, because I think it's an interesting area, especially with 3D printing. I mean, that's as localized as you can possibly get, and even though it's expensive, does seem to be what the future is shaping up.
Yeah, I was thinking along those lines. With proliferation of 3D printing. I mean, at least from a theoretical point of view, if it's possible to also get the right materials to be able to print, and I don't know what quality or what level of 3D printers will be needed to deliver this, but if it's possible to do it on a distributed scale, I think that would be very powerful, and people can easily have access around the world.
Yeah, there's I can't remember the name of it, but the NIH on their website, they have a 3D print, the 3D print exchange. And so they have a COVID-19 program specifically for 3D printed medical devices. And so they've partnered with the FDA and the VHA, who I also worked with on this project early on. And they're figuring out, there's very stringent requirements for 3D printing medical devices. So you'd have to use a printer like the one I have back here, or like an MJF. Because there's 2 issues with it. One is to ensure that the prints are very high quality and don't have microscopic holes where the viruses can leak through. And then the second part is bioavailability. So making sure that the plastic that you're using doesn't cause sores on the face, that is hypoallergenic. And then also that when you're breathing in those fumes, there's off-gassing from the plastics. And so, with 3D printed PPE, at the start of the pandemic, it was an amazing response just with like distribution and getting devices to the hospitals that needed them most. And it was just rapid, and it was amazing. But at the same time, it created issues because, people were printing with plastics that were off-gassing, and, you wear that long term, it's going to end up harming you. The same way with just fitting of the masks. And so these things were unregulated. And while it filled a gap, again, it created more problems. And how do you solve for those problems? So that's something that I want to take a look at within and exploring that.
So your mask is autoclavable, right? Or it has to be autoclavable?
Yeah, I think it's UVC light is coming along really well, and I think some hospitals are switching to it. It's a lot cheaper, probably more environmentally friendly. But yeah, autoclave is that would be like the standard for it. But that's the thing, is I have to take a look at the materials and how they respond to being in that high pressure, high temp environment. I think temperatures are probably most important for killing a virus. But yeah, it's going to be you have to consider both just how well it kills a virus, how environmentally sustainable it is, and then how much it breaks down the material. And we have to find the right material sterilization process that's going to work the best.
Have you tried with silicone? Because you can pour silicone and it's not so expensive, and it's fully autoclavable, and I think it's hyperallergenic.
Yes, it is.
least
Yeah,
that's- yeah.
silicone's the standard for medical devices for sure.
Yeah, yeah.
It's but the problem is it's not, there are more, like I think TPE is recyclable and silicone is not. So, ideally like to find a, recyclable solution if that's possible. Again, there's trade-offs with each thing. Number one, the FDA is not going to prove it unless it's hypoallergenic. And so, and possibly autoclavable too. But so silicone is going to be the standard for that. But maybe there are new materials that people are coming up with that that may work now or in the future. You can start making masks now, and maybe they're not quite as environmentally friendly. And that's what Tesla's doing with cars. The cars aren't necessarily environmentally friendly yet, but we're working towards that. Solution in the future.
If you can autoclave silicone for like 500 times, that actually is probably better than recycling something after five uses. And
it might be, yeah.
Yeah, so that shouldn't be too much of a problem as long as you recycle the filters and the other parts that are not autoclavable.
Yeah, for sure. It's a lot of data, a lot of things to consider, and I'm adding a lot of complexity to it. But as we get further along, we'll be able to narrow down some of those areas and mark some areas for future improvement later on. All right. Thank you for the discussion and questions. So I'll give everybody their 10 minutes back, and so as you prepare for your next meeting. So take care, everyone.
Thank you, Hunter. Take care.
Bye.